Hello everyone, in this video I would like to show how can we set up the Ethernet communication between the Allen-Bradley CompactLogix and Beckhoff controller. And in this test, we will use the Allen-Bradley CompactLogix EL62 as an Ethernet master or scanner. And Beckhoff system, we will use the software solution to implement the Ethernet IP slave function into the Beckhoff controller side. To implement the Ethernet IP slave function in the Beckhoff side, we have two ways. One way is we use TF6280, this software way, to implement the TwinCAT Ethernet IP slave function. Another method, you could use EL6652, this hardware run as an Ethernet IP slave. But most of the cases, I believe people will turn to use this TF6280. This solution, that's because we only need to use the built-in Ethernet port and use this software, this solution to implement the Ethernet IP slave function. For example, if we are using CX9020 controller, on the controller, we have a two Ethernet port. We can use one of this Ethernet port, implement this Ethernet IP slave function. And another beautiful thing is to test this function, Ethernet IP slave, we can use our laptop to implement the TwinCAT controller and test this function. We do not need to purchase any hardware. So to do this test, you only need your laptop and one Allen-Bradley CompactLogix controller run as a Ethernet IP master. And our laptop will run the TwinCAT controller and run this Ethernet IP slave. Okay, to check out the detail, highly recommend you can download this document. Basically, the following test, we will follow this TF6280, this menu. Okay, let me show how can we implement that. So firstly, let's create a new project. And my current software, that is 4024.7. So select this TwinCAT project. And I will name my project TwinCAT project ETH. And I will set up my project under this directory. Okay, click OK. Okay, and next, let's go to the PLC, create a PLC project, add a new item. Under this directory, I will select the standard PLC project. And the PLC, I will name PLC ETH slave. Okay, click add. Okay, we set up the PLC project. And then let's go to the devices. Right click, click add a new item. To allow the built-in Ethernet port to implement the Ethernet IP slave function, so we will go to the Ethernet IP, select the Ethernet IP, and we will see here, this is the hardware option, so EL6652. If you are going to use the hardware to implement this slave function, you can select this hardware. And if we are going to use software only, so you can select this adapter slave. Click OK. And not only this Ethernet IP adapter, so in this system, for example, you are using the EX9020, this controller, you could still have other devices. For example, that is the EtherCAT E-bus. So you could also have other input-output modules. So probably you can add new item and select this EtherCAT and select the EtherCAT master. And under this EtherCAT, probably we could still add a new item, select this EK1200, this EtherCAT power supply, for example. And then under this EK1200, we could select the digital input and the digital output, for example, the EL1008 A-channel digital input. And let's add the digital output, for example, the EL2008 A-channel output. This is your normal control signal modules. That is a device 2. And this device 1 allows your controller built-in port to implement the Ethernet IP slave function. Okay. So this is just a demonstration. And to use your laptop to implement this controller, so we have to use this disable this EtherCAT function. If you are using one actual controller, so you can enable that, and this is the same hardware configuration in your system. And because I'm going to use this virtual machine run as a Beckhoff controller, so that's why I disable that. So only enable this Ethernet IP adapter. Okay, and then let's go to here, double click. So at this 8000 parameter, so this RW area that allows you to type in the parameter. And this RO, that is a read only. Okay, we can see the important parameter here, basically these 3 lines, that is the IP address, network mask, and gateway address. Okay, keep in mind here, the IP address here, this is one virtual IP address, and that is the actual slave IP address that Ethernet master need to find. And this IP address should not be the same as your Beckhoff controller. For example, in my case, my Allen Bradley controller, its IP address is 192.168.1.191, and this Beckhoff controller, my laptop, is 1.192. And this Ethernet IP slave, I will assign that IP address is 192.168.1.193. Okay, my controller, my Beckhoff controller is 192, but this Ethernet IP slave, that is 193. This is one virtual IP address. Okay, so this network mask 255.255.255. Okay, and gateway IP, that depends on your case. So probably in this case, I can select 192.168.1.1. Okay, select OK. Basically, we set everything at here. Okay, after we set this IP address, let's go back to this TC EIP adapter. Here, we need to set some hardware configuration. And then let's go to the adapter, this page. Click this compatible devices. And we need to install this driver. Click this install. This will allow our Ethernet card install the driver. And this driver is a real-time Ethernet driver, like this Ethernet IP communication or Profinet real-time RT communication. We need to install this. If you are using the Beckhoff controller, so the Beckhoff controller already pre-config or pre-install this driver, but I'm going to use my laptop to do this test, so I need to manually install this driver. Okay. And here, let's switch over this page and make it fresh. And then let's click this search. This allows this page to select the Ethernet port or Ethernet card we are going to use. Again, if you are using the Beckhoff controller, here, that card you are searching, that is the Beckhoff controller Ethernet card. And I'm going to use my laptop, so this is my virtual machine Ethernet card. We assign using this Ethernet adapter to implement this Ethernet IP function. Okay, and then let's shift to the Ethernet IP. And here, this is net ID. And this address will be used within the Beckhoff system. Basically, we will leave this assignment as a default. Let's go to the synchronized task. So highly recommend this synchronized task. We need to special assign one synchronized task. If our main, the PLC task, that cyclic time is 20 milliseconds, probably this communication, this synchronized task, we can set 10 milliseconds. That is shorter than the normal PLC task. We could create this I/O task here, or we can go to the system here, create a task. So for example, if I create a task here, this is by default, that is a PLC task. If this PLC has a heavy job, for example, that cyclic tick, that is 20 milliseconds here. So when we set up the communication task, we can set 10 milliseconds. Okay, we set up this TwinCAT task. And we can rename this task as Ethernet IP communication task, ETH task. And this task, we can set a 10 milliseconds. And this priority, should be a higher than PLC task. The smaller value, the higher priority will be. So for example, if the PLC priority is 20, and this ETH communication task, we can set that is 19 or the 15. For example, I set 15. Okay, here, that is smaller than the PLC task. This priority will be higher than PLC task. Okay, after we set up here, let's go back to this adapter setting here. And this synchronized task, so this time we can select this ETH task. Okay, so the parameter will pull here. And then this diagnostic history and this online status we can check when you go online. And basically we'll finish the configuration here. And then go back to this box here. And from here, we will create this append I/O assembly. So if you did this Ethernet communication before, you could very familiar with assembling this name when you set up the EDS file. That is true. That is this area. So let's create this append I/O assembly. Basically, this area is used to set up the communication buffer input and output. So let's click this input, right click, click this add a new item. So the name, we can name the input here, that means the data flow from the Ethernet master to the slave, to the Beckhoff side. So we can name it, that is the master to slave. And our unit, we can set up as a byte, as a unit. And multiple, how many bytes we can set. For example, let's set up 8 bytes for testing wheel. It starts from 6 because the system has some status value here. Okay, let's click OK. And then you will see, so it create master to slave, this input signal. We create 8 bytes here. So if we double click here, that unit, the type is a byte. When we set up the communication, we can select this online and we can check out the actual status. Okay, this, I will rename it. So there has 8 bytes here. And then let's go to the output. Click add a new item. And this name, we can name it slave to master. Okay. Byte. Same thing. Let's create 8 bytes here. Create OK. So that unit is a byte. Okay. We can rename it _1. We create 8 bytes here. And after this, we can go to the global tag list and declare the bytes. And after the declaration, so we can click this link this hardware channel to the software, the variable tag. Okay, let's go to this global, add a global variable list. So I will call that ETH, open. And here, I will firstly declare one communication status. That communication status tag or variable will be used to connect here. This input connection status. So we can declare that connection status AT% input star. And that data type, that is a udent. Okay. And that is a status. And then we will create 8 bytes for this input buffer and 8 bytes for the output buffer, for example. So we will create AB to TC3. So byte 1. That is 80% %I star byte. Okay. Allen Bradley to TC3 byte 1, and follow this way. We will create 8 bytes. Okay. For the output, so that is a TC3 to AB byte. And this time, this is the output. Output is Q star. Okay, so follow this way. We create 8 tags. Okay, we declare those input and output variables. Their unit is a byte. And after this, let's click this build. We must build this project first. After this build, so those tags will be declared as a variable in this system. Okay, it shows us we haven't connected this tag yet, so it's true. Okay, no problem. We are going to do that. So after we declare this, so firstly, this input, the data from the master, from Allen Bradley side to the Beckhoff side. When we double click this buffer, click this link to, because that is an input for the Beckhoff system. So here will only show the input variables. So that is the ETH, that global variable list name, and Allen Bradley to TwinCAT 3 byte 1. Okay, click OK. And after we connect here, this arrow will show the difference. You can see that. And same thing, we connect all other tags. And this connection state, click this link to. And because this is a connection state, that is a udent. So we only have a one udent. It will only show this variable. So click OK. When this tag change to 1, that means our connection is not correct. When this value is equal to 0, that means everything okay. This could be used as a state, showing one red indicator on the HMI, show the communication status. Okay. For the output, this is the buffer transfer the data to the master, to the Allen Bradley side. So this slave to master, the first one, click this link to. Click this ETH dot TwinCAT 3 to Allen Bradley byte 1. Okay, so the icon will show the difference. Okay, next one, same thing. At here, we connect all those tags. Okay, at here, we connect all the tags. And after we create this assembling, when you go to this box, this Ethernet IP slave here, we will find, so it create 8001, this area. For example, the configuration instant and the input instant and output instant, those parameters are the key parameter when we set up the EDS file or the generic file from the Allen Bradley side. Fortunately, we do not need to manually set this. So after we configure this everything, the IP address, those interface, set up how many bytes we need to configure, and which adapter we need to come out, and what the IP address this virtual Ethernet IP slave will be. So after all those done, so we can click here, right click this export EDS file. And from the Allen Bradley side, we can import. Okay. So before I export, I would like to build all the solution. Check out till now if the project has an error. So everything shows okay. And to allow my virtual machine, this system, to run this Beckhoff TwinCAT project and run this Ethernet IP slave, I need to check out the license first. After we create this Ethernet IP slave, this TF6280, so we can go to the license side, we will see this license will show up. So if this is the first time you are going to test this function, so you need to click this 7-day trial license and type in the same characters here. So that allows you to do the test within 7 days. And once the license expire, so you can click this 7 days trial license again, and it will give you another 7 days. That's really beautiful. Okay. Keep in mind, so we need to enable this trial license here. And after this, to allow my virtual machine to run this controller, so I need to go to this real time. I go to this real time. Read from the target first and select this isolated core. Okay, and click this side. This allows one isolated core in this virtual machine to run this controller. Okay, so we clear everything. Let's click build again. Okay, no error, everything okay. Save the project, and then I will export this EDS file. So I will name it TF6280 underscore and the date. Okay, click the save. And after export the EDS file, we can download this side. So to download the controller, let's click this downstairs activate configuration. Start the run mode. Okay, and then click this login. This is the software side. Once we click login, and now it start to run. In our main, it doesn't have any program because for testing well, we just need to monitor the I/O. Okay, so we basically finish all the setting from the Beckhoff side. Let's shift to the Allen Branley side. Okay, this is the RS link. So firstly, from this RS link, this is my controller. That is a 1769 CompactLogix L32. And its IP address is 191. And after we config the driver here, type in the remote station 192.168.1.193, that virtual IP address for the Ethernet IP slave. So after we register the IP address here, so we can see, so this Ethernet driver already found this Ethernet IP slave from Beckhoff side, 193. And this is my controller. Okay, that means that Ethernet IP slave is running there. Okay, so this is my empty project I just set up. So this is my controller 191, that controller. Click the tools, click this EDS hardware installation tool. Okay, let's register the EDS file. So register an EDS file. Register this file. Next, so it named box 1 and TwinCAT 3, Ethernet IP slave. Okay, so click next. Next. Okay, after we register this EDS file, let's find out this CompactLogix Ethernet area and right click add a new module. And here we can search Beckhoff. So it can search this box 1 we just installed. Okay, click new and click this create. Okay, and here, so we can name it a TwinCAT 3 PLC. Okay, and the IP address, that is 192.168.1.193. Keep in mind that is 193, the virtual Ethernet IP slave address. Okay, here. And at here, we can see the connection, that is assembly 1, input and output. That is the same name as the Beckhoff side. And if I click this change, so that is the 12. The reason why that is a 12, because we set up 8 bytes, but the 8 bytes is after 4 bytes. That 4 bytes, that is the status of the connection. Okay. So connection here, we can set up this RPI, this cyclic time here. And click OK. Now we are creating, so click OK. And after we set up this connection, so this controller tag is show up the input and output here. So let's download this controller. Compile and download. Let's run. So the controller is running. Firstly, let's double click this station. So let's watch this status. It shows running. That means this controller is communicating with this Beckhoff controller now. Okay, and now let's go to this controller tags. And this connection faulted shows 0. That means the connection is correct now. And this input area for the Beckhoff controller, that is the data from the Beckhoff. And this output, we need to control, we need to set the value from the Allen Bradley side to the Beckhoff side. For example, this date 4 here. So using the decimal, we can set 66, this value. And let's set up this 77, okay, and 88. And 99. So let's shift to the Beckhoff side. Okay, this is the Beckhoff side. So firstly, let's double click this variable list. From here, we can watch the tag or variable. So we can see the Allen Bradley 2 TwinCAT 3. This buffer, it shows the same value. 66, 77, 88, and 99. That means this communication is correct. So if we set some value to this buffer, that is the buffer we transfer the value from this Beckhoff to the Allen Bradley side. For example, we set, click this prepared value. So we set 11, 22, 33, and 44. Okay, we set up the value to this 4 bytes. So click this write value. Other than here, so we can also click all of them. Right click, click this add watch. So add those values to this watch list. So we can set or monitor the value in this watch list. Okay. And also, we can check out this connection status. Now it shows 0. 0 means the communication is correct. Okay, 1 means it's not running. And now everything shows okay. Let's go to the Allen Bradley side and check out those values. Okay. Okay, so after we shift here, we can see from this byte 4. So from this byte 4 here, the value received correctly. From the Beckhoff side, this value. From Beckhoff side, we send 11, 22, 33, and 44. And the connection is correct now. So if I disconnect the cable, let's see the status. So from the Beckhoff side, we can check out this status. So because I disconnected that controller, I cannot reach that Allen Bradley controller anymore. We can double click this connection state and go to this online. So we can see now this value is equal to 1. 1 means this connection is not running. Connection has an error. And if we go to this variable value, so this connection state shows 1. So you can use this 1 showing as a red indicator shows this connection got something wrong, right? So that is the Ethernet communication between the Beckhoff and Allen Bradley. We can see this process actually is quite easy. And keep in mind, this manual, TF6280, this manual is very useful. Basically, I saw this manual one time and followed this manual step by step, and around 1 hour, I figure out this connection. Okay, that is for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.